Good morning. We are going to get into Unit 8. Welcome back to school. Unit 8 is all about exponent rules and scientific notation. Our first one is going to be on exponential products. Exponential products means that we are working with multiplication, multiplying. Okay, remember, when you say a product, you are multiplying. Let's get into this lesson. Here we got some just examples of powers. Okay, when we're talking about exponential products, we're talking about exponents. 3 to the first power is how you read that. 3 to the first power, which just equals 3. When you got 3 with a little 2 there, that's 3 to the second power, or we call that 3 squared. 3 times 3, it's 3 2 times. Okay, 3 to the third power, or 3 cubed. 3 times 3 times 3. 3 to the fourth power, or 3 to the fourth, 3 times 3 times 3 times 3. You notice that however many of 3's here is the number of exponents here. Okay, so 3 to the nth power, or 3 to the nth, it's 3 times 3 times 3. Whatever number this n is, the n is the number of factors that you are going to have here. Okay, this is called powers. Or a better way, we call them exponents. Okay. We say that the product of repeated factors. Okay. So let's see this example. If I want to change this into an exponential product, what I would do is I would say, well, how many 2's do I have? My big number is 2, and it is repeated 1, 2, 3, 4 times. So it's 2 to the fourth power. Okay. This here, that is your exponent, also known as your power. Okay, this big number, we call this the base. That is your base number. Okay, so two different numbers in these. You have your base number, that's the big number, and then the power is the smaller number up top, also known as an exponent. Okay, when we do this in a calculator, you would write it as 2, and then you're going to press the button that looks like this. It's called a caret. And then you're going to write the number of the exponent. I'll show you here on my calculator. We're going to write 2. We're going to press the caret key, which is right under the clear button. And we're going to write 4. And we're just going to press enter. And that's how we would do that on a calculator if you're using the TI calculators. Okay. Even power numbers. These answers will always be positive. This is for working with, sorry, I should have said this first, positive. This is for working with negative numbers. So like if I have an even power, if I have negative 2 to the 6th, okay, remember when we talked about this, we put these in parentheses. Your answer is going to be positive. This is a power rule. If you have an odd power, so like negative 2 to the 3rd, that answer is going to be negative. Negative. So any negative number to an even power is going to be a positive answer. So negative 2 to the 14th, negative 2 to the 2nd, negative 2 to the 24th. All of those are even powers. Your answer is going to be positive. If you're odd power, 3, 7, 21, 33, okay, those are going to give you a negative answer. Negative 2 to the 7th power will give you a negative answer. Okay, let's keep going here. We're going to fill out the table in expanded form. When in doubt, expand it out. Okay. If I have the expression 2 to the 4th, that's going to be written like this. 2 times 2 times 2 times 2. Okay, this is called repeated multiplication. And then I'm going to multiply that by 2 to the 3rd power, which is 2 times 2 times 2, 3 2's. If I were to simplify that, I would say, well, how many total 2's do I have? And I can count them up. 1, 2, 3, 4, 5, 6, 7. There are 7 2's. So simplified, this is going to be 2 to the 7th power. Okay. Again, when in doubt, expand it out. When I am taking negatives, I do the same thing. Negative 3 to the third, that's negative 3 times. Negative 3 squared is negative 3 2 times. And you should always do that as well, but I didn't. Okay, when we count them out, how many total do we have? We have 1, 2, 3, 4, 5. We have 5 negative 3s, so that's negative 3 to the 5th. Notice, as I'm doing this, our rule is when the bases are the same and we multiply them together, we're going to add the exponents. Notice I added 3 plus 2, which is 5. 4 plus 3, which is 7. Let's keep trying and show some more examples. 4 2 times, 4 squared, times just 4. How many total? Well, notice that there's no exponent here. So what does that actually mean? That means that there's a 1. You have 1, 4. Okay. Then we add our exponents together. 1, 2, 3. 2 plus 1, we get 4 to the third power. It works the same with variables. X squared is just x 2 times. X to the fourth is just x 4 times. And we can add them up. 1, 2, 3, 4, 5, 6. There are 6 x's, x to the 6th. And notice 2 plus 4 equals 6. Works the same with fractions. 1/2, well, that's 1/2 to the first power since there's no number there. So that's just 1 1/2. And then we have 3 halves. Oh, that was the wrong number. I had number 3 in my brain. Okay, then how many halves do we have? 1, 2, 3, 4. So our answer is 1/2 to the 4th power. Now we have 3 terms, but they're all x's. First one, we have 3 x's. Second one, we have 2 x's. And then on the third one, we have, again, 3 x's. So we can just add them up. 3 plus 2 is 5, plus 3 is 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 plus 2 is 5, plus 3 is 8. So my answer is x to the 8th power. Remember, what pattern do we notice here? We said when the bases, that's that big number, are the same, add the exponents. And that is our power rule. One more time. 2 3 times in expanded form, and then 4 2 times. Well, this is a little weird, isn't it? Well, we're going to have 4 times 4. That doesn't change. However, if we simplified this down to get 4, you know that 4 is the same as 2 times 2. 2 times 2 is 4, and 2 times 2 is 4. So now, how many 2's do we have? 1, 2, 3, 4, 5, 6, 7. So our final answer is going to be 2. Oops. Sorry about that. 2 to the 7th power. Notice that we can break down these perfect squares to simplified form. Okay, we're expanding it out. The condition of this pattern is that the bases must be the same. And I change this base from a 4 to a 2 times a 2. Change this base from a 4 to a 2 times a 2. Awesome job. That's it for video 1. Come back for video